7. So everyone should have their books open to lesson 7. Burke. And today we're going to keep talking about relationships between two different things. And we're going to talk about, we've been talking a lot about how relationships between two different things can sometimes be proportional relationships. And we're going to look at some things today that do not form proportional relationships. And we're going to be able to tell the difference between the two today. So the first thing to start things off, we're talking about a recipe. And this particular person, their recipe, they like to mix the juice of 5 lemons with 2 cups of water and 2 tablespoons of honey. So that's the recipe that they like to make. All right, and we're going to create our own recipes, 4 of our own recipes. And the first one, I want you guys to think of a recipe that would make more lemonade than that original one, but that would taste the same. Okay, for the second one, I want you guys to think of a recipe that would make less lemonade as the original, but it's going to taste the same. Now for the third one, on the bottom of your page, you're going to come up with a recipe that would have a stronger lemon taste. And then for the fourth one, you guys are going to come up, and the fourth one's on the next page. Okay, you're going to come up with a recipe that would have a weaker lemon taste than the original recipe. Okay, so it's up to you guys on your own to make 4 different recipes based off of the original recipe. Okay, I'm going to give you guys about 1.5 minutes. Ready, set, go. And you can just write L for lemons, W for water, and H for honey if you want. It makes it easier for you. We're on the first part of lesson 7. Should do the last one too. Okay, I want to hear what you guys had to say for your recipes. So we'll go through these 4 recipes, determine what kind of recipes you guys came up with. So there's not one correct answer. There's a lot of different correct answers we can have for these. So for number 1, Jocelyn, what is a recipe that would make more lemonade, but it's going to taste the same?
10 more lemons, probably.
Okay, so what's our total amount of lemons?
5. Wait, 10.
So we're going to use 10 lemons. How much water? How many cups of water?
4 cups.
4 cups of water. And then how much honey?
4.
Okay, 4 tablespoons of honey. So what Jocelyn did there is she doubled the recipe. She took 2 times the amount of lemons, 2 times the amount of water, and 2 times the amount of honey. So that would make the same tasting lemonade, but there would just be twice the amount. Nice, good job. Okay, then number 2. Tell me, what recipe would you make that would taste the same, but there would be less total lemonade? Sienna, what did you say?
2.5 lemons.
Okay, so there's 2.5 lemons. How much water?
1 cup.
1 cup of water, and how much honey? 1. Okay, so what Sienna did there is she just took the original recipe and divided everything by 2. Half the amount of lemons, half the amount of cups of water, and half the amount of tablespoons of honey. Nice, good job. And I know that these first two recipes that Jocelyn and Sienna came up with, they are basically scaled copies of the original recipe. And I know that because for each of them, I'm either multiplying by 2 or dividing by 2. But because I'm doing the same thing to every ingredient, that means this is a proportional relationship between the new, between all of the ingredients, and I'm just scaling it to make it bigger or smaller. All right, now number 3 is a little bit different. So what is a recipe that would have a stronger lemon taste than the original? Cloud, what'd you say?
10 lemons, 1 cup of water, and 0 tablespoons of honey.
Nice, okay. So this one is going to be 0 cups of honey, 1 cup, or 0 tablespoons, 0, just no honey, 1 cup of water, and 10 lemons. So we realize that what I realized here is that Cloud doubled the amount of lemons and then reduced the amount of water by 1/2, and then also just took the honey out of the equation completely. So this is just basically going to be a very, very strong lemon water. All right, there you go. That works. Okay, very strong, very strong. Now, I want to hear from Emma. What is your recipe that would make a lemonade that has a weaker lemon taste?
I said 2 lemons and 4 cups of water and 4 cups of honey. I mean 4 tablespoons. 4 tablespoons of honey.
Okay, perfect. Yeah. Oh, why did I put honey there? That would be, what did you say, 4 again?
Yeah.
Okay. So what Emma did there, she took the original recipe and she took fewer lemons, but then she took more water, more honey, but fewer lemons than the original, and so that would create a weaker lemon tasting lemonade. Yeah, I agree with those. So the thing I want to point out though is that when we look at these, number 1 and number 2, they are scaled copies of the original recipe. But number 3 and number 4, they are not scaled. And they're not scaled because we're not doing the same thing to every ingredient. All right, nice. All right, let's go on to this next question. So this next question tells us that when we're visiting a state park, the entrance fee to a state park costs $6 per vehicle. So that means it doesn't matter what kind of vehicle goes into this state park. It could be a bus, it could be a motorcycle, it could be a car, it could be a truck. Doesn't matter what kind of vehicle it is, they charge a minimum of $6 per vehicle, plus they charge $2 per person in the vehicle, okay? And so they set up a table for us here to determine the total entrance cost in dollars for a various amount of people that they come in this, but they're all in the same vehicle. So I'm going to do the first one for you, and then I'll let you guys follow suit, copy what I do, and follow the method that I use for these other ones. All right. So for this first one, if there are 2 people in the vehicle, we know that there is 1 vehicle, so it's going to cost $6. Okay, plus it's going to cost $2 per person. So that's going to be 2 times the amount of people. Okay, so it's going to be 2 times 2. Okay, and then if we do 2 times 2, that's 4. So it's going to be $4 plus $6 for the car. So it's going to be a total of $10 for this car to get into the state park. Okay. All right, and now I'm going to let you guys do the same for if there were 4 people in that car and if there were 10 people in that car. And then number 2 asks us to do something different. It says for each row in the table, if each person in the vehicle splits the entrance cost equally, how much will each person pay? And I think this is going to be the easiest if we just add another column to this table and then extend the rows a little bit further. And we're going to call this column cost per person. All right, and the cost per person is basically, we're just going to take the total entrance cost and we're going to divide it by the amount of people. Okay, so if I have 2 people and it costs the entire car $10, then how much does each person have to pay, Morgan? So it's 10 total dollars, and then 2 people have to split that cost. It's going to be $5 a piece. Yeah, so it's $5. All right. So I want you guys, just like I did here, find the total cost, and then also tell me how much it's going to cost per person if there were 4 people in the car, and if there were 10 people in the car. Okay, so on your own, ready, set, go. And then if you finish with that table, including the extra column, then you can move on to number 3. So use that formula. Remember, it's going to be 6 plus the amount of people in the car times $2 a piece, because they charge $2 per person. What's up? What are you talking about? Yeah, exactly. That's what I'm saying. Every person has to put in $5. So it's like if you and I went to the park, you'd have to pay $5, I'd have to pay $5, and then we would make up like $10. Yeah, but this one's a little bit different here. Now, if there's 4 people splitting $14, then it would be $14 divided by 4. And if you guys need to use a calculator for this, you can come get a calculator, but make sure you get the one that corresponds to the number on your table.
I didn't see you when I was passing back to work earlier.
Okay, again, if you need to use a calculator, grab a calculator. These are going to be kind of hard to do without a calculator for some of you guys. Yes. What's up? Well, you got to find what you're multiplying or dividing by and one to the other. You can, but you just have to make sure you do it with the same squares as one. So if you divide this by times, that's fine. You do that on every single. Okay, so then check it by doing it. And the reason that doesn't make sense is because I'm going to talk to you guys about this in class. Right now. Nice. Good job, Bert. It's not going to be $5 every time. Look at this. And it's not going to be $20 here, so it's going to be $6. Well, okay, so $6 plus 2 times 8, or 2 times 4 is 6. It's $4, $2 per person. So that's going to be 2 times 4 is $8 plus the cost of the vehicle, which is $6. 8 plus 6 is 20. That's $14 for that. No, look what I did up there. It's $6 plus 2 times the amount of people. So if there are 4 people, that's 2 times 4. $8 for the people, and then $6 for the vehicle. 8 plus 6 is 14. That's going to cost 14. Well, actually, nice, good. Okay, but check this out. It's not going to be 8. Always start with 6. $6 for the vehicle, and then 2 times the amount of people. Good. Okay, looks like most people have this, so let's go through and fill this table in here together. All right, starting with if there are 4 people in the car, then Burke, how much is it going to cost for that entire car to get into the park?
$14.
$14. I would agree because we know it's going to be $6 for the car. And then it's going to be 2 times the amount of people in the car, so 2 times 4. So that's going to be 8 plus 6, which is $14. All right, nice, good job, Bert. So now if there are 10 people in the car, then Stice, how much is it going to cost them?
$3.50.
No, we're talking about the total cost if there are 10 people in the car.
Oh. 26.
Yeah, it's going to cost $26 because it's going to be 6 plus 2 times the amount of people, so it's going to be 2 times 10 because every person, 10 people, have to pay $2. So that's 20 plus 6, which is $26. All right, now going back to cost per person. If 4 people are in the car, it costs $14 total dollars. Okay, and so we got to take that $14, and everyone in the car is going to have to pay an equal amount. So they say, hey guys, we're going to have to each pay how much? Angela, how much does each person have to pay?
3.5.
Yeah, so 3.5, which is the same as $3.50 per person. Okay, now if I have 10 people in this car, and it costs $26, then they're going to say, hey guys, we each need to pay the same amount. How much is that going to be, Isis? So again, it's $26 for 10 people. How much is it going to cost? How much is each person going to have to pay? 2.6, which is $2.60 per person. Nice, good job. Okay, so as we can see that the more people we cram into a car, the less it's going to cost. Why do you think they do it like this? Why do you think the state park makes it so that the more people you fit into one car, the less they charge you? Why would they give people an incentive to put more people in a car? What do you think, Eden?
Less pollution.
That is true. It's less pollution, right? If everyone drove their own car into the park, well, in this last scenario, that'd be 10 cars instead of 1, so it's less pollution, less CO2 being emitted. What else, Richter?
To get more business.
To get more business, maybe, but how would it affect business? What do you think, Riley?
Well, mine is different.
Well, yeah, what's yours?
It's less space, so they can fit more people into the park.
Into the park, yeah. Have you guys ever been to, sometimes you go to state or national parks and the parking is really hard. So there's not enough parking spots for everyone. So they want people to carpool so that they don't have to provide as many parking spots for all the vehicles in there. Cloud, what else?
What if you walk there?
Usually they have a different fee for people who walk into a park. Yeah. So it'll be a completely different fee.
It's
Dumb that they charge for people walking in?
Yes.
Yeah, I mean, some parks do and some parks don't. I mean, I don't know about this particular state park they're talking about. Okay, so we're going to use that same formula I did right there. So I want us to answer number 3. So, how might you determine the cost for a bus with 50 people? And I want you guys to talk to your table partners, figure out how much it's going to cost, and then make sure everyone at your table understands how you get that number, okay? So everyone at your table needs to be able to answer the question, how much is it going to cost 50 people to get into this park on a bus? Okay, ready, set, go, with your table partners.
I don't fit $200.
What?
So if it changes, then it's not a proportional relationship.
You mostly get it wrong.
You wouldn't be able to, so all it's asking is saying, is the relationship between distance, time, travel, and time proportional? This one it is, because you're dividing by the same number. This one is not. So you're not proportional. I don't know, it depends on, you have to do some work there for it first.
Okay, Nora. If I have a bus with 50 people, so everyone should be listening to Nora. If I have a bus with 50 people, how am I going to figure out how much it's going to cost everyone?
You multiply 50 by 2.
Okay, so let me start there. So we know there are 50 people, so we need to multiply that, 50 people. We need to multiply that by 2, okay, and that's 100. And then what do I need to do? Or is that just it? I think there's something else we need to do, because that's 100 for all the people. And then what else do we need to do, Olivia?
Add 6.
Add 6, yeah, because remember that every car, no matter how big or small, it's $6 for the car and then $2 per person. So it's $100 for the people, $6 for the car. That's going to be a total of $106. All right? But that's not bad because you're splitting it between 50 people. So if we have $106, if we had to pay that ourselves, that would be quite a bit. But if you split it between 50 people, it's only $2.12. So that's actually not that bad. It's pretty cheap. All right. So now number 4. And this is going to help you guys. I've had a lot of people ask me this on about their homework. There's a question on your homework. There's a question on your quiz you're going to have to take on Wednesday about looking at a table and determining whether or not that relationship is a proportional relationship. And I'm going to show you guys how to do that now. And I'm going to simplify this table into the 2 pieces of information we need to know. All right, on one side, it's the number of people. And on the other side, it's the total cost. Okay, and we said if there were 2 people, the total cost would be $10. If there are 4 people, the total cost would be $14. If there are 10 people, the total cost would be $26. Now here's the thing, guys. If this relationship between people and cost is a proportional relationship, then we should be able to multiply the number of people by the same number to find cost every single time. So if I have number of people is 2, we determined that it's going to cost each person $5, right? 2 times 5 is equal to 10. All right, but that number changes when we have 4 people. It's no longer, because look at this, 4 times 5 would be 20, not 14. So this one we have to multiply by 3.5. And then this one, if we have 10 people, each person has to pay $2.60. So do you guys see how we're multiplying by different things every time? This is not a constant of proportionality because it's not constant, it's changing. And if we have to multiply by a different number to get from the left side to the right side of a table, then this is not a proportional relationship. So for number 4, and I want everyone to write this down because this is going to help you on a lot of different questions you're going to see coming up. It asks, is the relationship between the number of people and the total entrance cost a proportional relationship? And I'm going to say no, because there is no proportional relationship. Or no, there is no constant of proportionality. If there is no constant of proportionality, then this is not a proportional relationship. And again, a constant of proportionality is a number that I multiply the left-hand side of an equation by to get to the right-hand side. If it changes, it's not constant, and that's not a proportional relationship. Okay? Let's take a look at one more example to illustrate what I just said. Okay, this next part. We're talking about 2 people, Han and Claire, and they're running laps around a track. I love this example. This is the kind of math I love to do. Okay? So, Han and Claire are both running laps around a track. Okay, and the coach is recording their times at the end of every 2 laps. So at 2 laps, he records their time. At 4 laps, at 6 laps, and at 8 laps. And for those of you who are unfamiliar with track, 1 lap is 400 meters, or 1/4 of a mile. And so therefore 2 laps is a half a mile, 4 laps is a mile, 6 laps is a mile and a half, and 8 laps is 2 miles. So they're running a 2-mile race right here, all right? And so what we're going to do is figure out their minutes per lap. So we're going to find a unit rate. Remember, a unit rate is when we find one of something. Here we're finding how many minutes it takes them to run 1 lap. Okay, so this is a unit rate again. And does anyone remember how we find a unit rate? Remember when we were talking like miles per gallon and miles per hour? How do we find a unit rate, Riley?
Don't you like divide it by 2?
Well, what would we divide by 2?
You would divide 4 by 2.
You would. So, but it's not always being divided by 2. It depends on what the numbers are. But yes, we take the number of minutes and we divide them by the total number of laps. Is that what you're going to say, Eden? You're absolutely right. So for this one, if I'm trying to figure out how many minutes it takes this person to run, Han, to run 1 lap, then I would just do 4 divided by 2, and that equals 2. So we know he starts off running 2 minutes per lap. Okay? Now what I want you guys to do is to fill in the rest of this table and fill in the table for Claire's run by finding out how many minutes each person takes to run a lap based on how many minutes it has taken them to run 4, 6, and 8 laps. Okay, and then you're going to fill in this table. And then when you're done with that, you're going to answer question number 1. All right, so on your own, I want you guys to fill in the tables, use the calculators if you need to, and then answer number 1. Is Han running at a constant pace? Is Claire? And how do you know? All right, on your own. Ready, set, go. Grab a calculator if you need to. Remember, if you want to find minutes per lap, you want to find how much time it takes to run 1 lap, then you need to put 1 on the bottom, divide the top by the bottom. So it should be minutes divided by distance. Minutes per lap.
No, that is not correct. Give it to me. What do you mean? Which one are you?
Good, so all you have to do is minutes divided by laps. Minutes divided by laps. Do you have a calculator? Here, I'll get it for you. What number are you, Olivia?
21.
Yes. What's up?
What is the 1 equals 20? I don't know. Oh, you multiply by 25 and get 21. Okay, no, that's fine. Yeah, no, exactly. So if you write an equation for this one, it would be what do you multiply? So it would be like T times whatever equals D. Yep.
Okay, let's go through these. So, let's start with Han. Now, we know that he starts off running faster than Claire because his first 2 laps he ran in 4 minutes, where Claire took her 5 minutes to run the first 2 laps. All right, and then if after 4 laps it took Han 9 minutes, so what are his minutes per lap after 4 laps, Anna? After 4 laps, what are Han's minutes per, what is he running minutes per lap in? 2.25, exactly. So we would do 9 divided by 4, and that's equal to 2.25. Okay, so as we can see, if he started out running 2 minutes per lap, and now he's running 2.25 minutes per lap, then Angel, is he speeding up or is he slowing down?
Slowing down.
He's slowing down, exactly, because it's taking him longer to run a lap on average. All right, now after 6 laps, it takes him 15 minutes. So JJ, what's his minutes per lap after 6 laps? 2.5, exactly. So we take 15, we divide that by 6, and that equals 2.5. So overall, between 4 laps and 6 laps, Cloud, is he speeding up or slowing down?
Speeding up.
Really? Because it took
No,
him,
slow down, slow down.
yeah, it's 2.25 minutes per lap, and now it's 2.5 minutes per lap. So he's slowing down. And then finally, after 8 laps, the race is over. He ran it in 23 minutes. What was his average minutes per lap, Sienna?
2.875.
Yeah, so it's 23 divided by 8, 23 minutes, 8 laps, and that's an average of 2.875 minutes per lap. All right. Now we go to Claire. She has a different story. Okay, so Claire, after 2 laps, takes her 5 minutes. Then Emma, what's her minutes per lap?
2.5.
2.5, good. Okay, then she runs 4 laps in 10 minutes. So Shane, what's her minutes per laps on this row?
0.4.
It's not 0.4, nope.
Oh.
Gregory, what'd you get?
2.5.
Yeah, it's still 2.5. So Shane, we take the minutes and divide them by laps. 4 divided by 10 divided by 4 is still 2.5. Okay, after 6 laps, then Richter, what's her pace?
2.5.
2.5 minutes per lap. And then after 8 laps, what's her pace? Josh isn't here. Let's hear from Morgan.
2.5.
2.5 what?
Just 2.5. Yeah.
Minutes per lap, though, right? It's how long it takes her to run 1 lap. So overall, we can see that Han, is he either speeding up or slowing down? Olivia? Han?
Slowing down.
He's slowing down, right? How long it takes him to run 1 lap is getting slower and slower and slower every time. While Claire, is she speeding up, slowing down, or staying the same? Maddie? Voldorf? She's staying the same. Okay, so is Han running at a constant pace? We would say no. So Han is not, and I'll just say, and then is Claire running at a constant pace? Eden, what do you think? Is Eden running at a constant pace? Or is Claire?
There.
Eden is answering for Claire. So Claire is. Han is not, Claire is. So here's the thing, guys. If we were to look at both Han and Claire's run and ask ourselves, does Han's run represent a proportional relationship between distance and time? We would have to figure out, well, are we multiplying by the same number every time to get from laps to minutes? And what do you think? Is there a proportional relationship between laps and minutes for Han, Angelina? Is there a proportional relationship between laps and time for Han? No, there's not, because we're multiplying by a different number every time. We're multiplying by 2 and then 2.25. And then we are multiplying by 2.5, and then we are multiplying by 2.875. So as you guys can see, that this is not a constant of proportionality. So we would say that he is not running at a constant speed. His run does not represent a proportional relationship. Now Claire, on the other hand, she is just rock solid on her pacing. Every single lap, it's 2.5 minutes. So we multiply by 2.5 there, we multiply by 2.5 there, we multiply by 2.5 there, and we multiply by 2.5 there. So if I were to ask you, Does Claire's run represent a proportional relationship between laps and minutes? Riley, what would you say?
For what?
Does Claire's run represent a proportional relationship between distance and time? What would you say?
Yeah.
It does, yeah.